Hello everyone, welcome back to my channel, Monica Math Classes. I hope you have seen my previous videos on real numbers and polynomials, and you should have benefited from it. So now we will begin today a new topic, which is a pair of linear equations into variables. But before we begin, I want each one of you to like and subscribe the channel and also refer to your friends and relatives so that everyone can be benefited. They can also solidify their concepts well. So whether you're going to tuitions or not, it is not going to cost you anything, but you can again come back and revisit your topics. So before we begin, again, I'm going to say this, which is very, very important, that enjoy your learning journey. It's something really easy. You're going to enjoy it. So pair of linear equation into variables, which is something everybody knows. So you all are doing it from grade 9 and 8, right? So something we are going to build on. So let's begin. So pair of linear equations in two variables. This is your chapter 3 in NCERT, CBSE curriculum. So let's begin. So the first point is, what is a linear equation in two variables? So as the name suggests, it is saying linear equations. Okay. So when we say equation, equation means there is equal to sign. Okay. I will make equal to sign. Then it is called linear. Now in algebra, linear means the power of the variable or exponent of the variable should be 1. And when we say linear equation in two variables, so how it looks like? So it looks like this. 6 or 2x plus 3y is equal to 2. Don't you think it actually says the same thing? It is a linear. It is linear, yes, because the power of the variable is 1 in both the cases. It has two variables, x and y. Then it is equation because of equal to sign. So it is a linear equation in two variables. I hope this is clear. Now, whenever you get it, you will understand. But in general, how do we write it? We write it like this: ax plus by plus c is equal to 0. So this is a linear equation in two variable. A is coefficient, b is coefficient of y, and a is coefficient of x, and c is constant term, any number. Okay. Or if you want to show that there are two equations, because you're going to solve two equations altogether, simultaneous two linear equations. So you will write like this: a1x plus b1y plus c1 is equal to 0. And second one, a2x plus b2y plus c2 is equal to 0. So you have these two equations. So general form of linear equation, simultaneous, I would say, simultaneous linear equations is this. So it should be of this form. So understand this. So two variables, and the exponent or power of the variable is 1. And these are the two equations. So let's begin. So the question is, do you have solutions for such kind of equations? So answer is yes. There are many ways to solve such equations. So one is your graphical method, which we are going to discuss today. Okay. Second is your algebraic method. So graphic method we are going to cover today. Second is your algebraic method, which consists of substitution method and elimination method both. So in this, you will get both of them. Then we have cross multiplication method, which is super easy, a little different, but yes, nice. Once you have learned, you will do it. And second, you will get some complex equations, then which you need to reduce it to simple ones, like the linear equations you have seen in the form of ax plus by plus c is equal to 0. And then you can solve it. So you have to learn all these three methods in this chapter. And it's easy, like something you might have done in grade 9 also, how to solve equations. So graphical method is something new you have not done. So today we are going to cover it. So let's begin. So if I say graphical method means that you will get some coordinates, you are going to plot some points on the graph paper, and based on that you will get to know, you will interpret something on it. Okay, so graphical method of linear equations consists of two methods. One is called consistent method. 1 second. One is called consistent and second is called inconsistent. So let's talk about inconsistent first. So inconsistent means pair of linear equations. So first of all, understand we will always talk about the pair of linear equations. Pair means we will get two equations. One equation and second equation. So a pair of linear equations which has no solution means there is no solution. It is called as inconsistent. And second, we have consistent. Consistent means a pair of equation which has a solution, which you will see has at least one solution. It could be more than that also, but which has a solution, it is called consistent. Okay, so based on that, then we will study. And sometimes in MCQs, or sometimes they will just give you pair of linear equations and they ask you whether it is inconsistent or consistent. So remember, no solution means inconsistent. Has a solution means consistent. So if you have one solution, it is consistent. If it has infinitely many solutions, then also it is consistent because it's dependent. I'll explain you this word dependent later. So understand this, first of all, that what do we mean by consistent and inconsistent and how we can relate it to it. It's super easy. Again, I'm saying it, don't get confused with these two words and how it looks like, when you have the lines, how it looks like. Now check, I have actually got these lines to understand better. You have two lines. Suppose when you plot the coordinates on the graph paper, and when you join those points, you get some line. So when the two lines intersect at one point, okay, can you see? Okay, this is just an example I've shown. When two lines intersect at one point, then it has one solution. When it intersect at one point, means it has one solution. Okay, that means it is consistent. So understand this and remember it. When one solution means it is consistent. And when the two lines are parallel, it has no solution means it is inconsistent. So you'll remember it now. And when you have one line and there's another line on it, means the lines are coincident. It means it has infinitely many solutions. That time also it is called consistent. Okay, so when you have no solution, that means the lines are parallel to each other. They will not intersect any point. The lines parallel, those definitions you have learned in grade 6 and 7. So those lines are parallel. They will never meet. They will never intersect. So they are inconsistent. When the lines intersect at one point, it has unique solution, one solution, that is called consistent. And when the lines are coincident on each other, like your third case, the behavior of lines, can you see this third case? Then it is also called as consistent. It has many solutions. Okay, so a pair of linear equations, okay, which has infinitely many distinct common solutions, such a pair is called dependent pair of linear equations into variable. You will see one case where you will understand that how the two lines are depend on each other, how they look like. These two lines which you get on each other, their equations are exactly, equivalent. They are same. So you will get to know. So understand. So dependent is always consistent. So that's why this is our consistent. Now see, to understand better, what do you mean by this? So I have taken these three cases. Okay. So first case, if you see x minus 2y is equal to 0, 3x plus 4y minus 20 is equal to 0. And here it's written lines intersect. We have not solved it, but we are very confident that these two lines will intersect at one point. How? Now there is a trick which you have to remember. Okay. We have to compare both the equations with the general form of equations. Now, what is that? I told you your first equation is a1x plus b1y plus c1 is equal to 0. And second is your a2x plus b2y We will see the first equation, then you will understand better. Plus C2 is equal to 0. Now, you have to compare this general form of equation with the equation which is given to you. Compare the coefficients. Okay, so if I compare your first equation, x minus 2y is equal to 0. X is there, right? So what is the coefficient of x here? It's 1. Okay, and the second one here, a2, it is 3. So my a1 upon a2, if I have to write a1 upon a2, it is coming as 1 upon 3. Now next, I have to compare b1 upon b2. Now my b1, it is coefficient of y, it is minus 2. So you have to compare the coefficient, remember. X and y are the same, okay? Same variable, you have to compare the coefficients. Always we compare the coefficients. What are these? A1, A2, B1, B2, these are the coefficients of x and coefficient of y. X, coefficient of x, okay? When it is written, you have to compare with the coefficient of x. And in y, B1y, just compare the coefficient. It is super easy. Now, I have written minus 2 and here, then I am writing here down, I'm writing for B2. Now for B2, I have got this 4, okay? So 2 upon 4. Then I got C1 upon C2. Now what is C1 upon C2 constant term? It is 0. And for me, C2 is minus 20. Now check. Do you find A1 upon A2 is equal to B1 upon B2 or C1 upon C2? None of them are equal to each other. Here, if you see, A1 upon A2 is not equal to B1 upon B2. In that case, the lines always intersect. So we have certain rules now. You have to learn it. There is no way out because there are certain questions in your exercise when by just looking at the questions, you have to predict whether the lines will be parallel, whether the lines will intersect, or whether the lines will coincide with each other. So you have to remember it. Okay, so there is no way out. So sometime now you have reached in grade 10, you have to remember something. And this is one of those things. So there is a rule. When A1 upon A2, okay, coefficients of x is not equal to B1 upon B2, coefficients of y. That means the lines intersect. So that is one reason. Now I'll show you. And similarly, you can compare now second and third also by comparing the coefficients. And you will understand that what does it mean. I'll show you in the next slide. Then it is more clear to you. Now, check. We have the first pair of lines, x minus 2y. Now, a1 upon a2, which is coefficient of x. I have showed you how we get that. So here there is nothing, means it's 1 upon 3, okay, minus 2.4. Now compare the ratios. A1 upon A2 is not equal to B1 upon B2. It means intersecting lines as graphical, and algebraic interpretation is exactly one solution, which is unique. Second, 2x plus 3y minus 9 is equal to 0. Then you have second 4x plus 6y minus 18 equal to 0. Now, when you start comparing the coefficient 2 upon 4 and 3 upon 6 minus 9 upon minus 18, what do you see here? 2 upon 4 is nothing but when you reduce, you got 1 upon 2. 3 upon 6, when you reduce, you get 1 upon 2. Minus 9 over upon minus 18, you get 1 over 2. So all the ratios are equal to each other. They are equivalent. That means you will get in graphical representation as coincident lines. Okay, infinitely many solutions. You know, that's the behavior. On one line, you get another line. Okay, that is called coincidence. They're coinciding on each other. You'll get many solutions. Now the third case. When you compare the coefficient 1 upon 2 and you got here 1 upon 2 and then here you got 1 upon 3. A1 upon A2, when you see, your first two are equal, but the third one is not equal. That means you get parallel lines. Means no solution. There is no solution to this. So you have to remember, when the comparing the ratios, A1 upon A2 is not equal to B1 upon B2. Okay, coefficients of x is not equal to coefficients of y. That means you get a unique solution intersecting. Again, I'm repeating because it's very important. without, solving, you get to know what kind of graphical representation you will get. It's very important. You'll get, in your boards also such kind of question. So you don't need to solve, but when you're solving, you will understand my question is correct. Now, this next case is when all the ratios are same, coefficients of x, y, and the constant term all are same, all are equal. That means you're going to get coincident lines. It has infinitely many solutions. And the third case, when the two ratios are equal and it is not equal to the third one, means you will get parallel lines and it has no solution. So something very, very important you have done. And now you need to practice more such pair of linear equations that you can interpret what is the graphical representation and what is the algebraic interpretation of it. Yeah. So this is what you all have to remember. I hope that you all are with your notebook and pen and you're copying each and everything. So something what you're doing with me, and when you go back and practice it, it will help you to solve it, understand more better and solve it correctly. So this is something very, very important to remember. Now let's move on to the next part. If, they give you a pair of linear equations and they ask you that, whether it is consistent or not or inconsistent. Okay, 1 second. I think I forgot to ask you that. Now, if you have exactly one solution, unique and infinitely many solutions, both are the cases of consistent. Remember that you have either consistent pair of linear equations or inconsistent, and no solution means inconsistent. Okay, so no solution, inconsistent. Now let's see, we have to solve them graphically. Now can you see you got two set of equations, first and second equation. So this is my first equation and this is my second equation. So for this, you have to put it on the graph paper. So you need at least minimum 2 points. Now what are those 2 points? For first equation, I'm writing here for first equation, for equation 1, you need minimum 2 points for x as well as y so that you can plot it on the graph paper and you get exactly what is needed. Minimum 2, you can have 3 more to get more clarity. Okay, now I put x and y. Now I need to solve it further, x plus 3y is equal to 6. Now, if I need the value for y, that means 6 minus x upon 3. I hope you understand how to simplify the equation to get the value for y. It is transposition method. This x will go on this side, it become minus, and then to get the value of y, it will be divided. So now the first case, if I put in place of x here, in place of x0, so what will happen? If I put 0, so 6 minus 0 upon 3, 6 minus 0 is 6, 6 upon 3, you get 2. So you write down, second, you write down here 2. So you got your first point of x and y. So this is at that point when you put at x is equal to 0. So you can put any other point. I have put x is equal to 0. I got this 0, 2. Generally, we, start with the simple easy number 0, 1, 2, minus 1, 0. Whatever you feel like you can. But I would advise you to start with the smaller number so that it helps in your calculation too. Now, next, let's begin with the next one, which is at x is equal to, suppose if I say x is equal to 6. Why I took 6, this you will get to know. Why 6? Now in place of x, I'm going to write 6. So what will happen? 6 minus 6, 0 upon 3, which is 0. So for me, my calculation becomes much more easier. So I got 0. Okay, so I got 2 points. After putting the value for x, y I got x is 0, then it is 2, if x is 6, y is 0. Similarly, I need to solve this for equation number 2. I need 2 more points for this equation. So what I will get? So for that, I need to solve it first. X and y. And then here you go. Okay. So how do you get for this 2x minus 3y is equal to 12. Now, for such kind of equations, you need to get the value for y. So it is 2x. I'm transposing, right? Shifting, you're saying, shifting the terms. Minus 12 is equal to 3y. Because it's minus, it will become plus. Now to get the value for y, it is 2x minus 12 upon 3. Okay. So I got the value for y. Now, if I put in place of x as 0, what will happen? At x is equal to 0. So 0 minus 12, minus 12. So when I put x as 0, 0 minus 12 is minus 12. Minus 12 upon 3, it becomes minus 4. Yeah. And second, you want to put at x is equal to, what do you want to put? Suppose if I say x is equal to, make it 6, what will happen? 2 into 6, 12. And 12 minus 3, 12 minus 12, 0. 0 upon 3, it is 0. So 0, 6. Do you see? You got 6, 0 in the second equation, 6, 0 in the first equation also. So this is a common unique solution. You want to try something else, you can try. So let's take one more. So ideally, 2 is minimum, which is needed, but ideally you can take 3 solution as well. 3 values of x and y, because it is easy that where the lines are going when you plot it, when you join the dots. So now, suppose if I say at x is equal to 3. Now, 2 into 3, 6. So, 6 minus 12, minus 6 divided by 3, minus 2. So see, I got one more, 3 minus 2. So you should have, minimum. So I would advise everyone, each one of you, you should have calculated at least, 2 always is there. Otherwise, you won't get a line. You need at least minimum 2 points to join those 2 points to get a line. So calculate 3 at least, okay? 3 points are needed so that you get a more clarity when you draw the line. So you get these points. Now the next step is you have to draw on a graph paper. Now, I hope you know that how to plot it. So next step, I already have on a graph paper. So when you join these points to form the line, you will understand. Can you see here? Okay, so your horizontal is x-axis and vertical is your y-axis. Now, equal distances on the right side, it's all positive, up, it's all positive. Now, so A 0, 2, remember our first one, and then you have B 6, 0. Then here again for the second line, you got 0, minus 4, minus 3, 2, 0, and 6. So where when you join these, points and form a line, you will see these two lines are intersecting at one point. And what is that one point? 6, 0. B is the name which we have given. So we observe that, we are observing that 6, 0 is that common point or the common point to both the lines, right? So we will say that the given pair of lines are consistent. They ask us, remember in the question, they ask us that whether the pair of equations is consistent. Your answer is this. Yes. The given pair of lines are consistent and the solution is unique. At given pair of lines are consistent. And the solutions is unique. They intersect at one point, right? And solution is unique. So all of you, I hope that you understood today's class. And each one of you have to remember something very important, and that I'm going to revisit again. This is something which you all have to remember. The coefficients of x and y, the ratios which you get after doing that. So how do you decide that they will be intersecting if a1 upon a2 is not equal to b1 upon b2? Coincident when all the 3 ratios are equal, parallel when the 2 ratios are equal but not equal to the third. So all of you, I hope that you remember today's class and revisit on graphical representation of pair of linear equations, and this will actually help you to understand better. So again, I would say that practice makes the man perfect and permanent. So I want each one of you to practice again and revisit what we have done today, and see you again soon, very soon, in my next video, probably tomorrow, for the other half of pair of linear equations into variables. And by then, rise and shine, signing off, Monica. Bye.